Well, now we're doing the review for 9.2, and it says find the equation of a parabola and graph the equation, label the vertex, directrix, focus, and 2 points that define the lattice rectum. And the focus is at -2, 0. So here's the focus, -2, 0. Well, there's a couple of pieces of information we need. The vertex is going to be right here at 0, 0. So the directrix is at x equals 2. So that's our directrix. X equals 2. X equals 2. Now, here's our focus. Now, the equation we're going to need is y squared equals negative 4ax, where a is always positive because a is a distance. It's the distance from the vertex to the focus. So then a equals 2. Now we know this much. Y squared equals -4 times, and since a is 2, 2x. So y squared equals negative 8x. Now, let's evaluate this thing for x equals -2. So we're going to let x equal -2. So we get y squared equals, and -8 times -2 is going to be a positive 16. So y squared then, or y then equals, by the square root property, plus or minus 4. Say now we have the 2 points that define the lattice rectum. We go over 2 and up 4, over 2 and down 4, and this point is -2, -4, and this point is -2, 4, and these are the 2 points that define the lattice rectum. There's our vertex. We're going through -2, 4 and -2, -4. And let's see, we've labeled the vertex. Oh, I have to label the vertex 0, 0. The directrix, the focus, and the 2 points that define the lattice rectum. And we're done. Well, now we're doing question 2. And it says, graph the equation, label the vertex, directrix, focus, and the 2 points that define the lattice rectum. Well, here's the equation we're given, and here's the model of the equation we need. And notice, what's in the A position here? Well, it's 1. Well, that implies that A equals 1. And so now, what value of x takes this to 0? 2 does, so we'll go over 2, and what value of y takes this to 0? 3 does, so we'll go up 3, and there's our vertex at 2, 3. And since a is 1, our focus is going to be 1 unit above that at 2, 4. So our directrix is going to be 1 unit below that at 2, 2. And the equation of the directrix is y equals 2. Now, we just need, let's see, we've got the vertex, the directrix, the focus, and 2 points that define the lattice rectum. Well, notice, to find the lattice rectum, we'll let x be 4. So we're going to let x equals 4. I beg your pardon, we're going to let y excuse me, y equal 4, 1 unit above. Y equal 4, 1 unit above the vertex. And in doing that, we have x minus 2 quantity squared equals 4 times, and letting y be 4, 4 minus 3 is 1. So we get x minus 2 squared equals 4. So x solving for solving this, we have x minus 2 equals, by the square root property, plus or minus 2. And adding 2 to both sides, we get x equals either 0 or 2. And so our 2 points that define the lattice rectum are, one of them is 0, 4, and the other one is 4, 4. And now we'll draw our parabola. And there we have it. So we've labeled the vertex. We've given the equation for the directrix. We've labeled the focus and the 2 points on the lattice rectum, and we're done. Well, now we're doing question 3, and the reflector of a flashlight is in the shape of a paraboloid of revolution. Its diameter is 4 inches, and its depth is 1 inch. How far from the vertex should the light bulb be placed so that the rays will be reflected parallel to the x-axis? Well, let's draw a y-axis and an x-axis. Let's see, x, y. And now if the diameter is 4 inches, then we'll be 2 inches above and 2 inches below and 1 inch out. So here we are at 1, 0. I'll go to 1, 2, and 1, negative 2, and these points are on the curve that models the lens. And so now we know this. We're going to need this equation, y equals, or y squared equals 4ax. The issue what we need to know is what's a. That way we can identify the focus, and the focus is where the light bulb should be placed so that the rays will be reflected parallel to the x-axis. Well, let's pick a point on this curve. Since 1, 2 is a point on this curve, if we let y be 2 and square it, we get 4. And we have a 4a. Now we'll let x equal 1. So therefore we have 4 equals 4a. Dividing through by a, we find that a equals 1. So the focus is 1 unit away from the vertex. So we have the focus labeled right there. So furthermore, we can say the equation of this curve, although they didn't ask for it, is y equals 4x. But the focus is at 0, 1.